Welcome everyone to a new and special episode of the Tek Caffe podcast. I'm your host, 𝗏𝗲𝗄𝗏. Tek Caffe was launched in 2023 with a simple mission to empower the software development community through meaningful conversations. Since then, we've had the privilege of hosting some of the most insightful minds in our industry, including Tim Oettinger, Mark Richards, Venkat Subramaniam, and many more. A heartfelt thank you to all of our incredible speakers. Today, I'm thrilled to welcome back Jeff Langr, a master craftsman of software development with decades of hands-on experience that continue to shape how teams build and deliver software today. Thank you so much for joining us again, Jeff.
Thanks for inviting me back. It's always excited to be invited back.
Jeff has been delivering software systems since 1982. Through his company, Langr Software Solutions, he helps organizations build higher quality software while making the process more enjoyable. He's the author of 5 books on software development, including the 3rd edition of Pragmatic Unit Testing in Java with JUnit. Jeff also contributed 2 chapters to the best-selling Clean Code by Robert C. Martin. You can find links to over 120 articles and hundreds of blog posts he's written on his site, langersoft.com. This is Jeff's 2nd appearance on the Tek Caffe podcast. Back in August 2024, he joined us for a session titled Collaborative Development with Humans and Artificial Humans. That episode followed my attendance at one of Jeff's early courses on AADV and Create, Assess, Execute, or CAX for short, concepts he had just introduced at the time. A year later, these ideas have evolved into a mature and practical framework. Jeff writes regularly about AADV and CAX on his Substack, AI Code Correct, where he explores both concepts in depth. In my view, Jeff is one of the best voices in our field when it comes to using AI responsibly, and effectively in software development, addressing challenges few others talk about. And today we'll get to learn directly from him. To our live viewers, feel free to post your questions in the chat. We'll do our best to answer them at the end of our interview with Jeff. And now, without further ado, let's dive into the session. Jeff, the floor is all yours.
Thank you so much for the kind introduction, Ahmed. All right, so just to kind of recap, I think today we'll talk about some other things as well, but I want to recap the idea behind how I prefer to develop with an LLM at hand. Something I call AADV, and that just stands for AI-assisted development with verification. The key word in there being verification. Very first thing we all know about LLMs is that you can't necessarily trust what they generate. So yeah, you might trust it to the extent that it can produce some code that will run an application, but you're going to want to run this stuff. I mean, you're going to want to run it and test to see if it's got problems or not. And actually, that's a good old-fashioned slow way to verify the code that it builds. You could go with this whole notion of vibe coding, generate a whole bunch of code and then muck it, take a look at it, go peruse the code, and then try to verify it manually, pull up the app that it builds and test it out. And that's great if you're building a simple GUI or stuff, but most of us are building systems full of all sorts of wonderful bits of logic that we need to vet. Little things like off by 1 errors, little things like we didn't even specify how that should behave will manifest in defects if you let them. So the whole notion of doing AI development with verification means we're going to make sure that we have automated tests at the same time that essentially specify the outcome. And let me get that screen off the screen. So I'll start with a demo. And the idea behind the demo is I want to show the core process of this approach to software development with LLMs. This thing called CAX, C-A-X, and it stands for Create, Assess, Verify. So normally you just say, okay, go generate some code. You give it a prompt and you roughly describe what it is you want to build. The idea here is fairly simple. First off, we're going to focus on module by module rather than say go off and build an entire system. And I've done a little bit of that where I said, here's some spec for a bigger system. I find that the LLMs are still a bit limited. And I don't really want to get into letting them go off and build out the entire system. First off, just gathering that much specifications in the form of tests is pretty daunting. So my take is I still do a design when I put together a system. I lay out roughly what it's going to look like from a modular sense. And then I go back and start to drive into existence each of the modules that I want built by the LLM. The way I do that is with this CACS process. So with the prompt, I'm essentially asking the LLM to generate a module, code for the module, as well as the tests for the module. How do I do that? Well, I give it whatever information I would normally describe as a human in a prompt. So here I'm going to do an example of generating an encoding algorithm. This algorithm is actually called SoundX. Some of you might have heard of it. The idea of SoundX is we're taking a human name, Langr, L-A-N-G-R, and then from that we come up with a standardized code. Starts with a letter followed by 3 digits, and the idea is that if we have similar sounding names, Langr, L-A-N-G-R, with Langr, L-A-N-G-E-R, that might be spelled differently, they'll encode to the same number, and that way we can kind of quickly find, oh, we're looking for the wrong name, but here's some other things we can also search on. So SoundX is used anywhere that you might find people trying to search on human last names. So I give the prompt to the LLM here. I just give it a quick overview that says generate an encoding algorithm. I don't want to give away the fact that it's SoundX because SoundX is a known algorithm, and I don't want it to go and cheat and find implementations of such as a basis. And then I provide a little bit more overhead of rules. So use the following encoding table. So this is used for these consonants. We take a letter, encode it into a number. And then following that, I think is the crux of one of the things I found that works really well for generating appropriate solutions. Provide examples. The LLM itself will tell you, if you ask it, that they love examples. So I figured, this is 2 years ago, I kind of dreamed up a lot of this stuff. It's fairly simple to come up with these concepts. So a lot of other folks are similarly landing on this, or have been for the past couple of years. So the examples are, for me, just a description of some behavior. The very first one here says encode letters with consonants when up to 4 characters. Given, for example, ACDL, it should encode to A234. This is actually backwards. Normally I would do this as ACDL encodes to A234, but this is me sloppily copying and pasting from this morning from my rules. So read this backwards. ACDL is encoded into A234. Pad with zeros with less than 4 characters. So here I'm providing 3 examples to show that if I give it A, the expected value is A000. Ignore letters when there's non-alphabetics. Ignore any characters not in an encoding table. So this is going to ignore letters like A, all the vowels essentially, and maybe a few other characters. So when all is said and done, I provided a number of examples for what I expect the outcomes to be for the LLM. I'll go ahead and send off the prompt. And now that I'm on ChatGPT 5, it's going to, oh, actually, that was pretty quick. Sometimes it thinks for a lot longer. So that's great. It's giving me code. What I've also asked this GPT, it's called SID 6.7, to do is also generate the tests. I've given it a few background elements, given it some functional design style guidelines. We'll talk about those in a little bit. So I've given it some basically background information. And if you use Copilot, this is like providing the instructions, GitHub instructions .m markdown file. If you use Claude, there's similar mechanism for that. So you give it all the nice little constraints that you want it to adhere to based off of your preferences. One of these for me, as mentioned, is to generate test off also. So here we see encode.test.mjs. And what you'll notice is that the tests it produced, these unit tests written for JavaScript using Jest, are essentially a mirror of the examples that I provided. And in fact, what you'll see is the LLM will comply, and basically these will be close to 100% compliant. Every once in a while, they'll be a little off. Sometimes it'll add a word or two to the descriptions. But otherwise, you'll notice like it says it encodes up to 4 consonants and then expect A234 to be ACDL. If I come back up, there you go. That's very close wording to the example I provided, and then the exact same example that I did provide. Pad with zeros with less than 4 characters. I've got 3 examples there, and there we go. So right off the bat, I mean, we're starting with expecting outcomes, which is the best place to start with any system or module within a system. We're telling it, what does this thing need to do? And then you provide the tests that I can run. So if you think about a world with agents and whatnot, there's no reason you couldn't send this sort of information off to let it churn through the tests that are generated. Here, my first job, so I'm doing this more manually. I'm doing it in ChatGPT-5, which is where I started a couple years ago. I've certainly used lots of tools, including Claude along the way, Claude Code recently. And I find them nice, but now one of the beautiful things about ChatGPT, well, the new desktop client, is that it will do ingestion from your code base. It will also inject its solution into your code base using plugins which exist for WebStorm and VS Code. So that's kind of cool. So I'm back in here. I much prefer the interface for WebStorm to, I'm sorry, for ChatGPT desktop client to what you get out of Copilot and WebStorm. Anyway, for now, I'm going to keep things simple, and we'll just use copy and paste because it's not quite set up for the project to interact with. So what I'll do is I'll review these tests. That's the second step in the CAX process. First step is create both the test and the production code. So that's the C in CAX. The second step is to assess to make sure that the tests have fidelity with the examples you provided. And that's just a matter of scanning these and quickly saying, yes, these look exactly like the examples I told you need to meet for an outcome. Also in the background are some coding style guidelines. It is a fairly functional style. This is not quite an easily codable problem in terms of a functional sense. So I've actually found that this one tends to fail from time to time when I get it to generate. And this is one nice thing about doing this demo. Sometimes it'll pass, sometimes it won't. So you'll see first off that having the test at least lets you say, yep, there's a problem here. I need to try again, or no, all the tests pass and I can move on. The code style, yeah, there's some, you get into some fairly state-oriented stuff here where it's using local variables and not. And I think that's generally why this does tend to fail from time to time. I use another example heavily, something called name normalizer. It's able to produce a solution for that that is pure functional. And as such, initially 2 years ago, I was seeing that fail from time to time with the LLM generated code. In the past 6 months, I can't remember the last time I've actually seen a generated solution that failed any of the tests. So it's kind of interesting how that seems to have advanced in capabilities over the past couple of years. This we'll find out quickly. I'm going to go ahead. I think I copied the test already. So yes, let me paste those in. And then just to keep things simple in WebStorm, I will go ahead and copy in a solution and drop it just above. We don't need to worry about an export. So I've got tests below. I actually did this earlier this morning just to kind of warm up for my day. It failed then, and it had one glaring mistake, and I just told it about the mistake. I had it regenerate the code, not the test, and then ran it again, and the second time it did come and pass. Wow. Okay, so this is what's going to happen. I mean, this is life. This is generated code. This is human generated code. We make mistakes. The LLM makes mistakes. LLM's not as intelligent as us, and code is a fairly known quantity. It generally does a pretty good job, but here in this example, you'll see that it's not passing at all. You got one test about the non-alphabetic pads with zeros. Expected AX. Wait a minute. Received A. Yeah, okay. Right, so the X should encode to 2, and it should pad with zeros. But it didn't encode the X. I'll give it a second try, and then we're going to move on. But part of the point is to show you that it is don't ever trust the code that it generates to actually work. The only way you're going to know it works is by testing it. And really, the only sensible way to do that is with automated tests. You can generate them. You can generate them one by one if you're a test-driven development proponent. But it is so much easier to sit down, think through the problem, and then come up with a module's worth of examples and let it do all the dirty work of actually coding up those in the form of unit tests or other kinds of tests. You can certainly have it generate integration level tests and other sorts of tests. Let's give this another go. Back at the LLM. I'll demonstrate, and then let's see. Well, actually, let me tell it. That failed all of the tests except for the, which one did it not fail? Ignores alphabetic characters. Let's go ahead and run that. Actually, let me give it one more hint, which is I just usually often drop the failure directly in. Here's an example of a failed test. I don't want to get into this at a one-by-one level either. So the other thing I'm trying to do is not get in and muck with pieces of code. I just wanted to regenerate the whole module to the point where it gets it correct. Claude Code will do similar things for you now. The only thing about it is it'll do it for a good while and chew up lots of tokens in the process. Okay, let's see if this is any better. It gave me the test again. I don't really need the test again, so I will copy the solution and we'll give it a second try. And then for now, punt. And then I'll talk also about if I have to punt, what does that imply? Let's see, let's delete that and let's paste in the solution. And you'll notice it's a fairly different looking solution than what we just saw earlier. We'll run the test now. And then got one more. It got the one that I corrected it on. So I imagine if I went through this one test by one test, it might be okay eventually. I don't want to do that. Usually you discover that most of the failures are related to one thing it did wrong. One other thing you'll notice is I'm trying to make sure it generates decent looking code. This isn't bad, but it's still not quite as functional as I might hope. So often I'll give it hints to say, well, what if we were to extract this function into something smaller, or extract code from this function into something smaller. So I will give it design hints that lead in the direction of less stateful logic, and that often tends to help it shore up problems as well. Ultimately, you do care that by default, this stuff generates, these LLMs generate procedural code that's not very maintainable or even describable, since it's often a top to bottom solution. So the more that we can get it to break down the code into smaller chunks, units, if you will, smaller methods, smaller functions that each do one thing, the more you can have that sort of a conversation. With the top to bottom long function procedural code, it's really hard to tell it much. You pretty much have to say, well, try the whole thing again. Yeah, no, every once in a while it's going to get stuck on something that is fairly state focused. So you do want to be able to talk about the lower level building blocks, the functions within your modules, and negotiate through a solution. I'm going to give up for now. I'll come back to this later. I will show you from earlier today, I did essentially the exact same thing. So there, it says, okay, fixed it. it joined all of the solutions, or I'm sorry, yeah, it joined all of the encodings with commas, and it shouldn't have had any commas in there. Should be no commas. So I told it that. It regenerated this code, which you'll notice is a lot more smaller functions as well. There's not this one big long function with a loop in it. That one is over here in old, and this thing passed with flying colors, no problems. So CACs, you create the tests and the production code. A, you assess the test, and then X, you execute the test, and then you go through that cycle until things all pass. That's kind of the demo. So I'm going to return control to Ahmed, and we can talk about maybe some of the implications of this. I'll stop sharing.
Yeah, thanks a lot, Jeff, for the demo. So yeah, actually the demo has raised a lot of questions on my end, and we'll wait for questions from the audience. So of course, you've done many demos before, which I've watched, of course, and I see that AADV introduces several thoughtful practices, many of which, interestingly, are now showing up in tools like Claude Code, for example, which I will be asking a question on later on during the Q&A session. So I'm going to list 3 of these practices, and let's discuss them one by one. So let's start with the first practice, provide a style. You call it a style. Others refer to it as a system prompt, a rule, or a custom instruction, depending on the tool you're using. It's now foundational to how most AI coding tools work. Kent Beck and others have their own take on that. What makes a strong style guide in this context, and why does it matter?
So let's start with the latter part of that. The why does it matter? As mentioned, you can get away without specifying any kind of style. You can say generate some code. If you do, it'll produce procedural muck, because that's what the LLMs were predominantly trained on. The most code out there in the world isn't greatly designed code, and it is this top to bottom stuff that, ooh, you can stepwise read through it line by line and figure it out. But it's not the kind of code we want to maintain, right? Because problems bury in that procedural muck. It's harder to test, and there's all sorts of other, you don't get any reuse. We have a lot more code because of it, and so on. So there's all these challenges with it. And maybe the initial thought is, do I even care? If I am trying to wholesale generate a model, I'm not worrying about writing individual statements. I'm not using LLMs as a tool to assist me as a pair programmer might do if I'm doing test-driven development. I'm trying to use this as a tool to fully generate the statements of code. And then I can worry about what makes for good modules in a system, good building blocks, like, a function, nice interface that is assigned with each of those modules. So if I have that, then I have this notion of try to assemble building blocks into a system, to design a system that supports that in the first place, and then don't worry so much about the individual lines of code. But to do that, so you have to go back, though, to accept that it's going to produce the wrong code. So I just kind of stepped through a real quick example that showed, sure enough, it will produce code that doesn't work. And at that point, we do need to have a conversation. I think also there's in my head the notion that if you have it produce well-designed modules, the likelihood of compliance, the fact that all the tests are passing, that it generates, is much higher. I don't have proof for this. I did start to work on some research. It's been a busy summer, so I haven't had a chance to flesh it out. So if we have any folks on the line who would love to help with that, great. But I'm pretty sure it's true. If we give it guidelines to produce a better design within a module, it's going to have a higher likelihood of producing the correct code. So I think that's really why it matters. In terms of a strong style guide, I did experiment with this over the past couple of years, and essentially I distilled the rules I give it to a handful or so. I found oftentimes it will start to forget things. Given, I don't know why, limited context, limited in terms of how it's going to prioritize those things in the list of guidelines and so on, it drops things off. It forgets things. The code that you just saw generated, my LLM, that 𝗔𝗵𝗺 6.7 is set up to have those rules, and yet it seemed to ignore them this time around. I kind of forgot as I'm demoing. Actually, I'm going to go bounce over here real quick, and while we're sitting here, I'll say regenerate and make sure you apply my JS Jeff style rules. I give them a name. And this time we'll see if it produces a better set of code. So yeah, it forgets things. As such,
show your screen to show
I want to let it generate and come back.
Okay.
It's doing. It says now it's thinking, because it's like it wasn't happy that I reminded it, and maybe that's why it didn't do so well, as it kind of ignored the fact that it was supposed to comply to a different set of rules. So yeah, now I can share the screen because it is starting to derive a solution. So yeah, sure enough, I said, just go ahead. And it said, fine, you want it clean, you get it clean, no commas, pure JS Jeff, tight and mean. And I am back to a very functional looking solution. And then now I'll just go ahead and wait for this to finish and copy it out again. So yeah, the reason why, I mean, a good strong style is going to have a small set of rules, and I'll show you what the rules are in just a moment. So I'm going to copy that out, go back over to WebStorm, drop it in this top half here. So that goes away, and paste, and go ahead and run, and we'll see if that helps. No, wait a minute. Is that the same code? No, that's not the same code. So yeah, it seems to be having some issues. I don't know. I'll have fun with it, and then I'll post a message to you and explain why it was not doing a great job. How disappointing. But that's LLMs for you. Like humans, they'll continue to make similar mistakes until you help it through that. Okay. So yeah, I'll bring over, I've got this document from which let's see, let's go ahead and delete all this stuff. This is my style guidelines, essentially distilled. And if you'll notice, let's see, everyone has something to do, more or less has something to do with creating small functions. The very first one is create small single purpose functions. Don't have local mutations. Am I sharing, by the way? Did I?
No, I was about to tell you that.
Oh,
you're not sharing.
Okay, share screen. All right, sorry. Share. This is it. Don't use local variables. Extract logic into functions, basically. I mean, more or less, these all point to the same direction, which is small, single-purpose, cohesive functions. Don't include comments, really emphasizing the fact that we want these to be self-describing functions. If you've got, let's say, a little functional pipeline going on with lambdas, extract any non-trivial predicates or lambda bodies, anything that has logic in it, off to a separately named function. And this tends to produce code that is very easy to follow, as well as is more likely to be correct as far as I'm concerned. All right. So yeah, there you go.
So Jeff, can we go back again to the ChatGPT interface? I just want to have a look back at the prompt you first gave to ChatGPT.
Absolutely. All right, so there we go. Here is ChatGPT. And I'll cover our videos to prevent that from distracting. Okay, so what would you like to say?
Okay, so I was wondering, why did ChatGPT decide to write this in JavaScript or TypeScript? And yeah, and why? How did it know that it's supposed to generate tests along with the production code?
It doesn't even know what its own name is. So yes, good question. And to answer your question, it is a custom GPT. They keep changing the interface, so I kind of forget how to edit it. Let me think. Do I right click? No. Oh shoot. I mean, for one, as meant so I can ask it to describe JS Jeff, and it'll come up and show those same rules that it's embodying. It's easy enough to create these. It's part of the UI. I think you have to go to a web browser now to edit the GPTs. Actually, oh yeah, I know. I remember now. So here's what it thinks JSGF is. And some of the stuff, sometimes it adds stuff. Well, yeah, this one didn't. So this should look very similar to what you just saw, and it does. If I go off to GPTs, you can then go to My GPTs and then SID 6.7. I want to edit it, so I guess there it is. And now it's going to open it up in a browser, so I'll bring up the browser. And then within here, it's much like providing a markdown file. It's just a GUI. So you give it instructions. I tell it what its purpose in life is. I give it a bit of a personality. Design rules for high quality code. There's the same 6 rules or so again. And then I also ask it to format a completion so that I can readily extract code. I've got a plugin I started to build. It says its default language is JavaScript. It uses that style. And there's JSGF one more time. And then it defines what examples are. So yeah, everything that you need to know is in here. This is, again, comparable to what you might provide in the GitHub Copilot instructions MD file for Copilot or whatever Claude Code wants.
Yeah, so thanks for sharing that, Jeff. So let's move to the second practice that I've captured from your demo. And it's not actually a practice, it's more of a kind of a method, and that is create, assess, execute, or CAX. And yeah, actually, Tim Oettinger was asking a universal shadow question, why does X stand for validate? It doesn't actually, and we're going to be talking about that shortly. So in a previous session you've done, Jeff, you've described this process as trust but verify. And interesting enough, we have a similar saying in Arabic, and that is حرص ولا تخون. It's the same meaning. So create is about designing a solid prompt and letting the AI generate the code. Assess is where we test it, and then execute is we see how it will basically run and what it will output. The question here is that where did this model come from, and how does it contrast with TDD and other XP continuous delivery practices?
Okay, first to respond to Tim, CAV, so the X is execute, right? X stands out in that word, so it kind of sounds okay. I thought about generate, assess, execute, which would be GAX, which doesn't sound very pleasant. So, you know, the acronym is the acronym. This stuff was dreamed up a couple years ago, and I just came up with something to quickly talk about. Yeah, V for verify would be all right, CAV, but now it sounds like a, you know, baby cow or whatever. All right, so yeah, where did it come from? I mean, this is me. I just gotten basically deported from a company, consultancy I was working for, and that company is in dire straits at this point. And had a couple months on my hands to start thinking about where does this LLM stuff fit in my life. And at that point in time, it was produced a lot less quality stuff than it does today. Still has lots of problems today. But I started playing with it and saying, well, okay, I love test-driven development. It's something I've done for 2.5 decades to build my code, and really found a way to do it quite well and quite effectively and develop faster than I would without it. So as a lot of folks out there, a lot of peers essentially tried the same thing. And I think you know, Kent Beck certainly did a lot of, is still doing what he considers to be a test-driven approach to doing things. What I thought at the time and still think is TDD, it's very incremental, very granular. You do it essentially tiny behavior by tiny behavior. And I tried and I thought, well, okay, this works sort of. But the other thing that comes along with TDD is this notion of refactoring the code every time you get it to work. And I thought, well, that seems to be churning unnecessarily. So for me, at whatever point the idea popped into my head and said, well, why don't I just try to have it generate an entire module? It doesn't seem necessary to worry about these incremental granular growth of the code, particularly if you're not going to care so much about what the statements do. You do care about I glance at the module and I kind of look for anything that's standing out like a sore thumb, any oddities in the code or things that's like, why would it even do that? And every once in a while that occurs. So it's worthwhile to take the quick scan. But I do truly want to scan it in the sense that Mike Hill talks about scannability in code. I'm going to glance through it, kind of get a sense of what the interface is to this thing, and then just see if there's anything that stands out. And that's generally sufficient. So yeah, I don't really think I need to worry about within a given function what the code looks like. So that's kind of where that CAX came from.
Yeah, so thanks for sharing that. Okay, so how does it contrast with TDD and other XP practices? We were talking about that right before we went live.
So, as mentioned, I think it is distinct in that it's not as focused on keeping the code clean every few minutes. That's what I'm doing with TDD. I write the test first off to describe the expected outcome. So it is very similar in that vein. I think that's a key part of CAX, which is we are trying to describe a system in terms of what it should do when it's done, right? Makes sense. Hey, we should know what this system has to do to be able to be something we can deploy. But yeah, where it differs is I don't worry about cleaning up the code with every little function that I'm writing, because if I'm handwriting code, yes, your code is going to get messy very quickly in life and you need to stay at top of it. Here, I'm just saying, look, generate the whole module, and as long as it works, I mostly care about its interface. How does it interact with other modules? Or how do other modules interact with it? I think the other thing that it certainly starts to approach in similarity is I think it meshes well with the notion of BDD, or behavior-driven development, also called specification by example, whereby we're laying out examples in the world to say, and that's what essentially unit tests are, is a description of a feature with one example that we make sure that that example passes in the form of a test. So BDD is this whole mentality around sitting down and saying, well, what do we need the outcomes for the system to be first? So I think that's its closest analog in XP.
Yeah, so you've mentioned BDD, and I actually had a question prepared for that. So yeah, in your demo, you show how using examples makes a big difference in the output that is produced by the LLM. So my question here is that, have you explored using formats like given, when, then, or Gherkin? And do you think this kind of pattern could help reinforce example-based thinking or testing when using AI and LLMs?
I'm lazy, so the form I came up with is basically simple. You can certainly do procedural kinds of things like Gherkin, where you say, well, and you're going to need to in many examples. Not everything can be expressed in functional form. So let's say you've got a bank withdrawal that you want to test. Given I've got a balance of $100, when I withdraw $50, then I should expect the system to say I have a $50 balance. I've certainly written tests like that as well for more involved things that do involve behind the scenes state, and it's necessary. They work just fine. When I'm doing this, I'm looking to minimize my effort in typing and putting all this stuff in place. So the simple arrow form for functional things seems to work just fine. Where I think all this matters is in the context of a team, and I've always loved behavior-driven development. It can be done very poorly, and a lot of shops did that, and I don't want to go into why, but it's wonderful as a means by which we get our team together around various representation on that team, from the test folks, from the business analysts or product folks, to the developers. The whole point of that process is to make sure we're getting folks together to talk about what the outcome should be. And we do so using essentially this given when then stuff, what I'll call, the examples, as a contract we can agree on. Well, I don't quite understand what this feature means. Show me an example of how it plays out. Oh, well, when I do this, the system says this, and I do that, the system says that. I expect at this point, this outcome should be in place. It's an example. Actually derives, if you think back to the 90s, we saw this thing called use cases, in which that was the whole point, is we describe an entire system through these narratives of interacting with the system. So we'll kind of look at BDD as an evolution of that. And now I'm kind of looking at what I'm doing with AADV as yet the next step forward in that. So we start with the descriptions of the system in these forms, and whether or not they're Gherkin, I think that's fine. Gherkin does have a very specific, a little bit of specifics, actually, to be honest. I think the given and the when and then and other keywords like and, it's pretty small. So with an LLM, it still gets the gist of it, as long as you're pretty darn, long as you're explaining your example well. So I don't know that we have to formalize a language, I guess.
Yeah. So I think we're going to be taking 2 questions from the audience. So question from Tim Oettinger: since the LLMs aren't very reliable pair programming partners, how are you mediating and reviewing each step? What about micro-commits, reviews, static checkers, and using LLMs to check LLM code as well? This is a very good question.
Yeah, so it covers a good amount of things too. So for the micro commits, certainly I worry about things at the modular level more. So I'm not kind of in the realm of micro commit. So a micro commit in test-driven development, excuse me, would be more like, hey, I get a test passing, commit, I clean it up a little bit, commit, clean it up a little bit more, commit, move on to the next test, and repeat the process. So since I'm not working at that granular level, I'm not quite as interested in doing things like that. So committing at the level of a module, and sometimes I will commit a failing thing just to have that history to kind of go back to, but most of the time it's, I got the module generated with CACs, it's passing, let's commit it now. As far as static checkers, again, I'm not so worried about a lot of the nits in the code that I used to worry about. I am, I'll leave all this stuff on in my IDE, so it's going to let me know very quickly if I'm failing linting stuff. So that's my level of review, is pay attention to what the linter is doing. If I don't like the structure of the code, regenerate it. Beyond that, if I using LLMs to check LLM code, that's to me more what the tests are for. If I feel that maybe something's looking a little bigger in terms of a solution than I thought, I will do things like ask it to basically generate tests for itself. I just came up with the examples, I generated the module, and it was passing the test. Every once in a while I'll use my little spider sense to say, you know what, go ahead and generate some tests now, even though you started with these examples. We generate a test that we generated from examples. And every once in a while it'll come up and say, well, okay, here's a test for this scenario, and maybe it's something that I hadn't thought of. So that's kind of a self-check to say, what am I missing in terms of deriving the examples in the first place? Give me ideas at points in time. So I think that there are other things that occur too. I will occasionally sense that there's a problem with it generating more code than is needed. So I'll introduce code coverage tools and run those as well to say, yeah, there better not be any uncovered code because I gave you this set of examples. One thing I have learned to do is to always tell the LLM, as part of my style guidelines, is to generate no more code than the examples specify, to treat the examples as pure specifications, and to not add any additional behaviors in the code.
Yeah, so I think your answer has raised actually many questions from Tim. So he's saying, why are you not worried about the nits in the code? When is something a key concern versus a nit?
So when I think of nits, I'm thinking of a typical system that people haven't tended to. So if I am coding my own stuff with TDD, I am compulsive about anything that the linters or find bugs or whatever the style checkers are telling me to do. Actually, I decide to turn off a bunch of them. But a typical system where people have not done that, you're talking thousands of little warnings that'll give you, like, you shouldn't be doing this because this could cause a problem. For me, over the years, I've kind of realized that a lot of those are very valuable and they will point out stupid things that you're doing. But in general, I've always trusted the test to really let me know when I have the system I want. There are stylistic preferences embedded in lint about semicolons. There are things that you don't use any types if you're in TypeScript because this can, represent problems. But for me, I just assume focus far more on the test. And as mentioned, I'll add tests to the point where I think they're exhaustive. So I'm not only writing unit tests, I'm also doing tests at higher levels, at focused integration test levels, where I'm using those to verify that this one module interacts correctly with a third-party dependency, let's say a persistence module. I'm also looking at more end-to-end tests to verify that this fits into a use case and make sure that we've enabled that behavior in the system.
Okay, so Tim has another question. Have you seen it generate invalid tests, either due to bad test design or else by copying the code from production into the test instead of testing the production code?
Copy the code from production. No, I've not seen that. That one's interesting. I have seen it generate invalid tests, and it was just it seemed like a little glitch in the matrix kind of a thing. As mentioned, most of the time the tests are close to 100%. With the examples that you provide. But every once in a while, we'll do something really odd. Sometimes it'll add tests that you didn't ask for. And then I have to kind of step back and say, look, take that out because maybe it's not the behavior I want. A lot of the times it will try to do things like add a test for handling null or undefined. I'm like, well, no, I don't want that specifically for the reason that I know this stuff is not going to take on a null quantity. But outright invalid tests, yeah, it does happen. It's pretty rare. I'd say, maybe less than 1% of the time it'll do
that. So a question from my side. Have you tried telling it to follow ZOM or zombies and seen whether that worked or not?
Yeah, thank you for bringing that up. Tim, who basically came up with the ZOM acronym, Zero One Many, something that James Grenning later expanded into zombies, with the B for boundaries, I for, I'm starting to forget now, E for exceptional tests, S for simple scenarios. I'm not even remember what the I is for right now. Interfaces. I think the I is focused around interfaces. It is a wonderful little acronym, and it really reminds us of the kinds of things we need to cover in terms of writing examples in the first place. We need to cover, does it work in a zero-based consideration? Can we throw zero at it or null at it? Can it deal with undefined things and so on? So there's a lot of characteristics of a zero-based test or example. One, can it handle one element? Can it handle many elements and so on? So these are the mnemonics here are great reminders to go through in your head a list of what do we need to fully flesh out this module. To me, it goes back to it doesn't make sense to code a module until you really understand fully what it does it need to be doing. This is a skill. It's not a really tough skill, but you do get better at it over time in terms of thinking of what are all the things we need to make sure we cover? What are the possible exceptional cases that can or should occur? What should we do in those cases? Should it throw an exception? Should it return a default value or so on? So we've got decisions and choices, which means this is still a skill we want to make sure we're developing in terms of how to build quality systems. And that does involve thinking and thinking up front about what are the outcomes of such systems. We can certainly change those decisions, but that's step one. If you want to generate a module that fully exhibits some subset of behavior that we can close off from the rest of the system, yeah, we have to understand what those outcomes could be. And to do that, we have to understand how to step through all the things in zombies. I think it goes back to one of my things I've been saying for a good while now, which is I've only said that LLMs should be generating code, and I don't want to look at that code. Everything else matters. Everything else we know about how to put together quality systems that we learned in the 2000s and ignored for the most part in the 2010s, we need to come back to understand what does it take to start to let us trust that an LLM could do the same thing for us. So I think that does mean looking again at things like single responsibility principle and open close principle to start to build very modular, very pluggable systems. The code itself is probably the one thing I love shaping and whittling code. I love refactoring code. I love making it look elegant. And yet here I am kind of saying, you know what, that doesn't matter as much. It does matter in the sense that doing so is kind of the basis for quality modules. But I'm not going to sit and examine every line of code in the solution it generates.
Yeah, so let's move to another question from the audience. I think you kind of answered that. So if you ask it not to include anything other than the example, does the generated code include any kind of input validation, error checking, etc.?
Yeah, as mentioned, sometimes it'll do that, and generally, you know, sometimes it's a good reminder that I need it, but most of the time I am trying to think through what are all the validations it should produce. If I'm in a mode where maybe I don't want to say this because it's not quite true, but if I don't fully think about or explore where the system needs to go, you know, I'll let it just do what it wants to get a sense of what I need to be reminded of. And that's kind of like a scratch pass at it. So it gives me some ideas. So certainly you can go into this in exploratory mode. You can also say, generate the code. And I've done this as well. And when it's done, I'm like, okay, what are all the things I'm not thinking of in terms of validations that I might want to add into the mix? So it'll give me some ideas for that. What I'll do then is I'll go back and write these in the form of examples so that it has a basis for regeneration down the road to make sure I've captured all this. I think, you know, it's the whole problem I have with vibe coding, which says go off and generate all this code. You know, what happens when you want to regenerate pieces of things? You don't really have the basis for it if you haven't generated the tests from the examples that you give it. So yeah, I absolutely, I think, Michael, it's a great question. Yeah, let it explore on its own at times. So you might think you have a good idea, and this is also why I'll ask it to generate tests as well, because you're going to miss things. You're going to miss some validations you might otherwise need. But this is no different, in all honesty, than our, you know, hand-coded human reality, where developers don't think of all the validations up front. And most typically, they don't have anything to remind them until later, until they actually have a defect in production. So here, at least, if you have the right mentality about how to use these tools, these LLMs, you might actually have it help prompt you for things that you're missing.
Yeah, so I think we'll take this question from the audience, then I'll move back to my questions. I actually like this question very much because it's actually the reason why I asked the question regarding JWT and Gherkin. So Garrick is a bit worried about stepping back and simply drafting a piece of writing as if it were a college essay than to traditional TDD. If so, does this approach concern you?
I'm wondering about the concern, but hey, you know, our kids are using this now to help write their own essays. So essentially plagiarizing from all the stuff that had come before. So it's a very cynical note in this. It reminds me of. I don't think we're drafting a piece of writing. As mentioned, you still need all the skills that you have built up over the years. You need to be a software designer. You need to understand what it makes to assemble modules to build a fully fledged system that you can deploy and hopefully have a chance of maintaining over time. Right now, if you try to have the LLMs build entire systems, first and foremost, it's going to have problems in the guts of it, and it's going to be really hard to ferret those out. So to me, this still requires that modular design mentality that we can use in both OO and functional systems to understand how to build modules that piece together well. You have to take concepts, though, and really, really hit them hard. Single responsibility principle, it's a nice little concept, but if you look at even the systems that we test-driven developers build, they're really not SRP compliant. Take a classic example of a web system where you've got routes and you've got a lot of different behaviors coming in and getting delegated from those routes. Almost every system I see, you've got a routes TS file or something comparable where we've aggregated all of the endpoints in one somewhat related set of things. That is not single responsibility principle. Each one of those routes is its own responsibility. Now, a truly SRP compliant system that was also open close principle compliant, which means we modify it by dropping new behavior into the system as opposed to opening up classes or modules and changing them, does require each one of those things to be in a separate module. If you want it truly closed, then you also use a third-party thing or build it yourself to essentially dynamically load new modules into the system. And at that point, you don't even have to touch any kind of an aggregation thing that says, oh, pull in all these routes. So we do need to, I think, for the short term, and I always say for the short term because I think a better AI will get us to the point where it can be trustworthy 100% of the time, and it's next generation. It is not LLMs. For now, I think that's what we have to do is look at ways to hit all these time-tested principles hard, and that means really adhering to mostly SRP and OCP in terms of how we structure the systems. So, yeah. So does it concern me? Yeah, in the hands of people who don't know much about building quality systems. This goes back to vibe coding. You and I talked about this before the session. I think you and I both worry considerably about what's going to happen with LLMs generating code in the hands of people who just don't care and who are just sitting there and chilling with their laid back vibes. We're going to get trillions of lines of code in very short order that are in pretty horrible quality. And then we'll feed those back into future models. So, yeah, I think it's bad. I think it's a little frightening in many ways if and when, not if, people start going whole hog on generating lots of code. And it's starting to happen today.
Okay, so since you've mentioned vibe coding in the wrong hands, I think I'll have to take this question from Hassan. So let's for now forget a little bit about non-developers using AI to generate code and build applications. Let's talk about the juniors and the mid-level developers. So Hassan is asking, do you recommend that junior or mid-level developers use LLMs, whether using CAGs or similar approaches? And if so, how can we make sure it doesn't negatively affect their foundational skills, especially early in their careers?
So let's see. This is akin to when I was in grade school, middle school, maybe, I don't remember. Calculators were, forbidden for a long time for us. You need to learn long division and how to properly produce, multiplication solutions and so on, because you need to understand the concepts behind it. And I do believe in that to an extent. I would say maybe what's important for developers nowadays coming into this field or just starting to grow in this field is you should always be collaborating with people who know more than you as much as you can to learn as much as you can as you build systems. As mentioned, the only thing really that isn't quite as valuable in the era of LLMs to me is the statement by statement coding. The problem is, I think what they're going to lose out on most is not the how do we design a system, but how do we solve problems. And to me, that's maybe the most important skill for developers. We can all learn how to properly design systems, follow good principles and all that, and that's all fairly straightforward. You get better at problem solving by solving more problems. I firmly believe that. I started to do these stupid little exercises at Exorcism and other sites because it did help me think every day, because I would tackle one of these every morning for several months. Help me think every day about how do I solve these little problems. And I think the more you get good at that, the more you get better at what does it take to think about building an entire system. What kind of problems do I need that entire system to solve, and so on. So I think therein lies the bigger risk of not having the junior devs do things themselves and think through things themselves. I can just ask the LLM, give me, how would I solve this problem? And it'll do a really good job of that. How do I code this? Well, it's going to do a pretty good job of producing the code. And yes, you're going to lose out on that skill some, but I kind of see that part as disappearing faster than anything. We've evolved over time from assembly language to high-level languages, so we started losing a touch of how to interact directly with computers with this higher level thing that translate into lower levels. In the 80s, I was writing my own sort routines, my own printer drivers, and that there's no need to learn how to do that. And by 2000 or 90s, that had started to disappear. So each one of these evolutions of how humans solve problems with computers has really said, you know what, we maybe don't need to learn about these lower level details as much anymore. So I think that's true with LLMs. Yeah, if I were to, so I guess my advice would be for junior mid-level developers would be pair more, mob program more, collaborate with your other fellow developers more so that you do learn these skills. Things that we had already started to abandon anyway. As mentioned, the 2010s were more the decade of let's build a nice and better JavaScript framework than learn how to build software in a higher quality fashion that we can actually stand a chance to maintain over time without increasing costs. That's a much better problem that we should have been focusing on. But as such, hey, look where we are today. Most developers don't use TDD. The vast majority don't. Most developers are not using a fairly disciplined approach like behavior-driven development to sit and figure out how do we, what do we agree on in terms of the various representatives of the company we're at. Most developers don't pair program or mob program. They're off on their own. They're producing a lot of code, and it's just the quality has been decreasing all these years. So I don't know. However we do it, I think it's certainly valuable for junior and mid-level developers to understand design. And all that will eventually disappear. I don't know if it's in 5 years, 2 years, or 15 years, but this certainly the writing is on the wall in terms of people who worry about a lot of low-level lines of code within some period of time. I think there still will always be a need for programmers. But for now, I do believe this approach I've taken, it's just one of many ways to look at things. I know it's not the end all. I think it's a great way for me to do work, particularly on a more greenfield thing. It's got its challenges when you deal with legacy systems. But I think it's a wonderful stepping stone and will suffice for that period of time until we get to a point of a next generation AI that you can trust.
Yeah, this makes a lot of sense. So I had a question regarding the limitations of LLMs, but I'm not going to let it be an open question like the one we're showing right now. I'm going to ask you specifically about refactoring. You must have used LLMs to try and refactor legacy code, dirty code, call it what you want. How was your experience using LLMs in refactoring?
Yeah, there's a few things in there. So first off, legacy code still remains our biggest challenge. I would suggest there's probably one book every developer should have read along the way, which is Michael Feathers, Working Effectively with Legacy Code. And I think I don't know. When you say refactoring, to me, it's kind of a loaded term. If I'm doing test-driven development, I do refactoring at a very incremental, granular level. I get my test to pass, then I look and say, how did I just degrade the design of the system? Or how did I code into the system and where did it result in something that is fairly hard to understand? So my first and foremost thing is to make sure that the code is clear and understandable. As mentioned before with LLMs, I don't really look at that as much anymore, but where the design still matters. So that's design. I mean, statement by statement, making sure the code is clear and expressive and lays out, let's say, a simple piece of algorithmic logic within a function. That still matters in terms of people being able to maintain it, and it is still an aspect of design. Where I do need to now worry more about it is at a modular level. I think I've created a nice SRP OCP compliant system where things are pluggable. Where it tends to start getting to be a headache is if I am dealing with a legacy system and I've got to drop things in place, because now I have to start giving it some constraints. Excuse me. You need to interact with this example existing module with its existing interface. And I think this is where the LLMs can struggle quite a bit. Things like Copilot, where it can even ingest the code, still have a hard time knowing what you're telling it to do. So I'll tell it, well, okay, interact with this function. And then it'll be like, okay, but then it doesn't recognize that that function exists in a module here. And it's a lot of back and forth. Where I've had to do any sorts of things with agents or whatnot, it'll just go off and churn for a while too. I think Claude Code is a wonderful little vacuum cleaner that sucks up tokens very quickly. I did something last week where it kind of went through, let's see, I'm trying to remember the specifics here. I don't want to. So I had it generate tests for an existing legacy module, and it generated the test, and they look good, except we're using TypeScript, not my favorite language. And if it were me, I wouldn't do this with TypeScript. But it had a lot of linter problems. Specifically, the biggest one was it put any types on things. So I basically spent a lot more, like 1 million tokens, just having it fix those. So that was my attempt at refactoring. I said, clean up all the linter errors. And it just churned and churned and churned. It took about several minutes, 3 to 5 minutes. I don't remember, but it was a long time, and I'd spent a lot of tokens. And meanwhile, I'm sitting there twiddling my thumbs, like thinking about other things. I'm not so thrilled, by the way, with the ChatGPT-5 that it's like, oh, you can go into, we'll default to slow mode, and I think you can switch that. And I'm going to go chew on ideas for up to several minutes. I'm not thrilled with it. But I realize, usually I do get better answers. I think I get better answers because I've usually let it do that. So I don't know. Anyway, so what was the question? What limitations? I think they tend to break down when dealing with existing code. So again, back to the concept of a design. A good design lets you plug and play. A good OCP compliant design. This is where all the object-oriented design patterns came from in the 1990s that a lot of people are like, well, we overdid that, so let's not do those at all. No, I think we need to go back to all these concepts about how to put together a maintainable system, at least for now, for this point, whereby the LLM's not going to be able to build the entire system itself and make that a closed quantity. At that point, all bets are off. But for now, we need to understand how to design a system.
Yeah, I agree with that. Okay, so I think you've mentioned that you've played around with Claude Code. This is the state-of-the-art thing in the AI-assisted coding stuff, agentic coding. You've obviously tried vibe coding, and now you've tried agentic coding. So how does agentic coding compare to vibe coding? Is it a step forward or just a different tool in the toolbox? Just to give people an idea about what agentic coding is, it goes beyond just generating code. It's actually able to break down tasks, plan, generate tests, fix bugs, and self-correct, which is the most important feature. So from a couple of trials and some reading, Claude Code, and Claude Code didn't pay me to say this, but they say that it doesn't generate code until it is absolutely sure, whether that be by generating tests or running some, some sort of checks, that it is correct. So that is a big difference. So what is your take on that?
I do think this is where everything is more or less heading. We're still going to need the human factor in for a good while, and this is why I focus on the starting with examples. Again, it doesn't matter. You can trust it to go off and build a whole bunch of stuff, but you can't trust that it's going to be exactly what you think you need in the system. So one way or another, we're always going to have to arbitrate what are the end outcomes of that system. You think about any kind of system we build, let's say insurance, any kind of financial system, whatever. There's lots of rules. There are lots of little tiny rules in that system that have to be exact. And maybe we'll learn to do less of that because the LLMs kind of promote that. But ultimately, you have to arbitrate and say, okay, if I give you X is 3 and Y is 10, then you should get 42 as an answer. Okay. Without that human intervention, then you're kind of asking it to go off and build something, and you're not even sure what you're going to have by the time it's done building with vibe coding. So agents are great. I think they are going to be how things are going to be short term. They'll hopefully get faster and spend fewer tokens and so on, getting correctness and so on. But ultimately, you still have to provide those expectations for outcome. So I think we're going to need humans in the mix for at least as long as I'm alive. It'll get less and less, but you're still going to have to arbitrate because the system can always choose one of two ways or one of infinite ways to come up with an answer. Is it the way that you want for the system that you're building? I don't know if it's an answer to the question, but yeah.
I do agree with what you've said, that I think agentic coding is on the right track, and I think that this is where the future is. And I remember in my first question when I said that a lot of the practices you have suggested in AADV are actually being implemented now in agentic coding. The way I see the future is going to be is that the AI coding agent will be able to check the quality and the correctness of the code, just like how we would do as humans. As you've said, using static code analysis, using tests, using whatever. Our job will be basically to say, okay, show me the tests. These look good. Proceed. Okay. And if it tells you, okay, I've done all the checks and everything seems to be okay, I think at that point we'll be able to trust it a little bit more than we do right now. And maybe then we will not care about the design as much, okay? Because we will know in the background it's going to, be doing all the checks we will be doing as humans. And it's a scary idea. I think that the same way that compilers led to us not worrying about how machine code works, I think that in the future we may not care about design, because the AI agent will care about that, and the only people that will care about the design will be the people implementing the agents, not the people using them. So I'm not sure if you will agree with me on this, but I think from our discussion, this is where I see this is going.
So design is to allow us to change, right? A good design, at least as far as human coding to this point in time has meant, good design means that you're able to change this thing over time. If you could build a system once and you never had to change it again, you wouldn't give a hoot about any of that stuff, right? And I think that's where things are headed. But for the interim, let's say, you know, tomorrow you could probably, with a set of agents, have it produce an entire system, and it would churn through quite a bit. And then you'd have something, let's say it got it to work because it passed all the tests. I think in the interim, we still have to worry about cost. I think still it'll be cheaper than, let's say, your average developer. But the question becomes then, what about update changes? So how does a poorly designed system respond to changes? Well, you'd have to give it all the same requirements, essentially, and say, here's a new one, and just regenerate the whole system. And certainly that's feasible. But I think in the interim, the cost part of the equation is going to be a big thing. Right now, you know, if I do that little thing I mentioned from last week, it costs maybe a couple, I think it's maybe $1 or $2. I don't know. It was cheap. But if I'm doing that all day long, if I'm regenerating modules all day long, doing more refactoring, more granular stuff that makes it churn more, it's adding up, and it is starting to become not cheap. And in fact, I can probably spend, you know, a couple $100, $300, $400, $500 in a day if I wanted to churn quite big things. So I don't know. I don't know. I'm guessing on the numbers, but I think there is certainly, for the time being, to do this sensibly and not blow a lot of money. I think we're going to want to think about, how do I get it to regenerate small portions? I have a tiny change. Do I really want to wait an hour or two for it to regenerate the entire system, or do I have a way to very quickly go to the code I need to and have it make a small change to that one module, or drop in a new module, more ideally? So I think for the short term, we do want to come back and look at how to lay out a system such that we can help the LLMs direct its efforts and tokens, or send our tokens to the place where the focus of change needs to go. So yeah, does that kind of address what you're looking for?
Yeah, that makes a lot of sense. But you know, as you were talking, I came to realize that many of the recommended practices we are following and you know, teaching people to do were based on the fact that it's humans that are coding. Okay, so you know, Martin Fowler has said any fool can write code that the machine will understand, but you know, not everyone writes code that humans can understand. And the whole point of design is making code easy to change. Okay, but who are we making it easy to change for? Machines or humans? It's humans, right? Is this going to change when machines are smarter and can be trusted to do more than what they do today? This is more of a philosophical question, but we'll have to wait and see. But I think in a couple of years, a lot of the things we have been doing and teaching, I think we will need to revisit if this AI thing becomes very smart and trustworthy. Okay, because what's the point of caring so much about design when it's not us humans anymore that are going to be maintaining the code and doing all the changes? If the machine is going to do the changes, well, let it do it. The machine doesn't care about a lot about design or readability or maintainability, right? If it's going to be able to change the code and deliver stuff, then so be it. But again, this is very philosophical, and I'm not sure we will reach there. But I think that, and again, this is not a compliment. In one of your Substack articles, when you have suggested using mutation tests and code quality tools in order to get feedback and know if we are on the right track or not. If agents use the exact same tools that we use as human beings to check for the code quality, if they use that for feedback and they do self-correction based on that, then I think we're up. There is something here. Okay. But yeah, we'll see how it will go. I see that our discussion has raised a lot of comments on LinkedIn, but we'll have to look at those after we're done. Okay, so let me ask you perhaps the last question, and maybe we can take a question from the audience. So I know you're working on a new book with a lot of other co-authors. So would you like to share that?
Work has been done. Actually, I think we were solicited. So Robert Martin, the clean code guy, one of the best-selling computer books in the past couple of decades, basically solicited chapters from several of us, Tim included, for a second edition of Clean Code. So yeah, I think I wrote mine somewhere around December, and I did one on emergent design. Tim did I think he did an update to the one on clean naming, which is one of the most important things we do in terms of a software's design for humans. I did the one on clean classes, and the second chapter I had written was on emergent design. And since then, I've kind of like, okay, simple design is a nice concept from Kent Beck, but I've kind of posited a slightly different take on it. Really, it's just saying, look, as a human, every few minutes you are writing code, you need to be cognizant of the impacts of the changes on the overall design of the system. So it's just basically hyper aware notion of design. And yeah, you can draw from no end of history and different techniques for what is good design. So we talk about solid, talk about Kent Beck's simple design rules, we talk about code smells and so on. It's just that the more you know about what is deficient with the design, the better a chance you have to start addressing it. So that chapter this goes into how might this start looking, and at the very end I do talk a bit about, a lot of this, at least for the short term, will matter in terms of if you want to start generating code. So we do, it does cover single responsibility principle and open close principle quite a bit. Don't know when the book's going to be out. I think Bob had said somewhere around October this year, but I have no idea. He might have dropped out the chapters. It was 1,000 pages the last time I saw. It was outrageous with a lot of material in it. And I know some of the stuff is going to get winnowed down. So we'll see what remains of it. I haven't heard from him for months, but very excited.
Yeah, we're all excited and looking forward to that. Okay, so I think we're done with our prepared questions, and I think we've answered all of the questions from the audience. I think that one of the really good takeaways from today's session is that there is still a lot of things to discuss about AI-assisted coding and development, and there are many opinions, and I think that we need to continue such discussions, and things are moving really quickly. We were having this discussion right before the session, and yeah, maybe next month we'll see something new, something that will surprise us all. But I think that the question is now no longer about whether we should be using AI or not, or whether it will continue or not. I think that AI is now part of the software development workflow, whether we like it or not. Is it going to continue? I think yes. Remember, a year ago, we were talking about the longevity of this AI stuff. This is no longer a valid question. We now have open models and the models that you can run locally on your machine, a lot of open source stuff, every tool now has a free tier that you can at least play around with. So I think it's going to continue on. The question is how to use this effectively and efficiently. And this is what you're doing right now, Jeff, and what other people are doing, like Kent Beck and Tim Oettinger. They're trying to basically tell people, well, this is what we have found out, and this is what we recommend that you guys do in order to use this new tool correctly. And thank you so much for that. And please continue. There is still, we can learn a lot from all of your experimentation. All right. Yeah. So Tim, thanks a lot for being with us today. That was a great session. And I do have one last announcement to make before we conclude today's session. So the coming up episode on the Tek Caffe podcast, Hassan and I are going to be doing a long-awaited session on refactoring legacy code with characterization tests. It's going to be a two-part episode. So the first part, we'll be talking about legacy code and how to write characterization tests. And of course, we're going to be using a real example for that on not a kata, but real code that was on production and was very poorly written, and we're going to refactor that. The next part is we'll talk about how to refactor the code after we've written the characterization tests. And we're not going to be using any AI in this. we want people to learn the core skills and concepts, and maybe in the future we'll do something with AI. So yeah, we'd like to see everyone in this session. It's going to be hopefully a good session. Okay, Jeff, again, thank you so much for being with us. We hope to have you again in the coming session. And to all our viewers and audience around the world, thank you so much, and we'll see you in the coming episode.
Yeah, thanks for having me. If you, by the way, send me questions on LinkedIn. Happy to respond to any that I didn't get a chance to see. Thanks for all the questions today, too.
For sure. There's a lot of discussions on LinkedIn. There's a lot to answer.
I'll take a look.
Okay, so we'll see you. Bye-bye.
Cheers.